Hi students, my name is T. Rajshekar, working as a lecturer in civil engineering, SRS Government Polytechnic, Sricilla. So today's topic is problems on parallelogram law of forces, subject engineering mechanics, and the chapter name is forces and moments. Forces and moments. Let us see problems on parallelogram law of forces. In the previous class, we have discussed regarding the parallelogram law of forces formula. Objectives: on completion of this period, you would be able to determine the resultant of two coplanar concurrent forces. As per parallelogram law of forces, magnitude of resultant R is equal to root of P square plus Q square plus 2PQ cos theta. So that is angle made by resultant with force P is given by alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. So let us see now some of the example of the problems. So example 1, if two forces 300 newtons and 400 newtons act on a body at an angle of 60 degrees with each other, determine the resultant by using parallelogram law of forces. So that means here the 300 newtons and 400 newtons are acting on a body at an angle of 60 degrees with each other. So let us see here, a 300 newtons and 400 newtons are acting on a body. So this is a point. So it is in the 60 degrees angle, that is known as resultant. Okay, we have to find the alpha. So that is force P is equal to 300 newtons and force Q is equal to 400 newtons. So this is determined as P and it is determined as Q. So angle between the forces theta is equal to 60 degrees. This is a 60 degrees angle. So we have to find the resultant R, that is magnitude of resultant R is equal to root of P square plus Q square plus 2PQ cos theta. So that we have to substitute here. The P was given 300 newton square and 400 is Q plus 2 into 300 into 400 cos 60 degrees. Then we will get 608.3 newtons. So this is the how much the R is acting is 608.3 newtons. Here angle made by resultant with force P is 300 newtons, whereas alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. So therefore substitute here to get the alpha angle. Alpha is equal to tan inverse of Q is 400, theta is given 60 degrees. So P is 300 plus 400 cos 60 degrees is equal to 34.715 degrees. It is equal to, press the degree symbol in calculator, 34 degrees 44 minutes 54 seconds. So the angle is nothing but alpha is equal to 34 degrees. So result magnitude of resultant is 608.3 newtons, whereas angle of resultant with 300 newtons force is 34 degrees 42 minutes 54 seconds. So this is the result of magnitude and angle of resultant. Let us see the example 2. The two forces 60 newtons and 100 newtons are acting at 90 degrees to each other. Calculate their resultant. So if the two forces are 50 newtons and 160 newtons and 100 newtons are acting at 90 degrees, so we have to calculate the resultant. Therefore, force P is equal to 60 newtons, Q is equal to 100 newtons. Angle between the forces is theta 90 degrees. Solution. So resultant of two mutually perpendicular forces given by R is equal to root of P square plus Q square. If suppose two mutually perpendicular forces are each other, in that case we have to take R is equal to root of P square plus Q square. So here 60 square plus 100 square is equal to 116.6 newtons. Therefore, angle made by resultant with the force P, that is 60 newtons. Therefore, alpha is equal to tan inverse of Q by P. Therefore, tan inverse of Q is 100 and P is 60. So, that is equal to 59 degrees 2 minutes. It is the angle made by the alpha. So result, magnitude of result is 116.6 newtons, whereas angle made by resultant with 60 newtons is 59 degrees 2 minutes. So let us see the more problems. So now see the two forces are acting at an angle of 120 degrees. If the greater force is 50 newtons and the resultant is acting at 90 degrees to the lesser force, calculate the lesser force. So that means here given data, let lesser force P is equal to how much and greater force Q is equal to 50 newtons. That means angle between the forces theta is equal to 120 degrees. So angle made by the resultant with lesser force, that is alpha, is equal to 90 degrees. So that means here how it will be there. So in this you can see the Q is 50 and the force P is how much, and the theta is 120 degrees and alpha is 90 degrees. So P is equal to lesser force how much? So solution, we know that the angle made by resultant is given by alpha is equal to tan inverse of Q sin theta by P plus Q cos theta is equal to 90 degrees. Here tan 90 degrees is equal to theta was given 120, Q sin 120 degrees by P plus Q cos 120 degrees. Then alpha is equal to, we will get P plus Q cos 120 degrees is equal to 0. Therefore P is equal to minus Q cos 120 degrees, that is P is equal to minus Q into minus 1 by 2. We know that Q is equal to 50 newtons. Substitute here P is equal to minus 50 of into minus 1 by 2. Therefore P is equal to 25 newtons. Therefore, result the lesser force P is equal to 25 newtons. So these type of problems will be giving in the examinations. Let us see the another example, example 2. So find the magnitude of the two forces such that if they act at right angles, their resultant is 10 newtons, and if they act at 60 degrees, their resultant is root 148 newtons. So given data, let the two forces be P and Q when an angle between the forces theta 1 is equal to 90 degrees, that is resultant R1 is equal to 10 newtons when the angle between the forces theta 2 is equal to 60 degrees. So resultant R2 is equal to root of 148 newtons. So therefore magnitude of resultant R is equal to root of P square plus Q square 2PQ cos theta. Substituting this, that is R square is equal to P square plus Q square plus 2PQ cos theta, that is in the case 1 theta is equal to 90 degrees. Therefore R square is given 10 square P square plus Q square plus 2PQ cos 90 degrees. Therefore P square plus Q square is equal to 100, that is first equation, and in the case 2 theta is equal to 60 degrees. R square is equal to P square plus Q square plus 2PQ cos theta, that is R square is 148 is equal to P square plus Q square plus 2PQ cos theta is 60 degrees. Substituting for P square plus Q square is equal to 100 from equation 1. Therefore P square is 100 plus 2PQ of 1 by 2. PQ is equal to 48. That is the second equation. So we know that P plus Q whole square is equal to P square plus Q square plus 2PQ. That is 100 plus 2 into 48 is equal to 196. Therefore P plus Q is equal to 14. So this is the third equation. As we know, P minus Q whole square is equal to P square plus Q square minus of PQ, that is 100 minus 2 into 48. So it's equal to 4. So therefore P minus Q is equal to 2. It is the fourth equation. Therefore P plus Q is equal to 14. It is third equation. P minus Q is equal to fourth equation. Therefore substituting here 2P is equal to 16. P is equal to 8 newtons. Substituting value of P, P plus Q is equal to 14. 8 plus Q is equal to 14. Q is equal to 6 newton. So therefore result the two forces are 8 newtons and 6 newtons. So finally here the magnitude of resultant R is equal to root of P square plus Q square plus 2PQ cos theta. This is the alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. The unknown values of P, Q and theta can be determined by using the above two equations. Let us see the few more examples. A force of 200 newtons and another of 300 newtons act at a point. If the angle between them is 150 degrees, determine the single force that can replace both of them. So therefore data given, force P is equal to 50 newtons and force Q is equal to 60 newtons. So here angle between P and Q is equal to 60 degrees, whereas this is the diagram, 60 newtons and 50 newtons. The resultant R, alpha is 60 degrees. So therefore to find the resultant R is equal to root of P square plus Q square plus 2PQ cos theta. Here it gets 95.39 newtons. Therefore, angle made by resultant with respect to 50 newtons force, that is alpha, is equal to tan inverse of 300 sine 150 degrees by 200 plus 300 cos 150 degrees. Therefore, the value you will get 33 degrees, that is the alpha value. The next is a force of 200 newtons and another of 100 newtons act at a point. If the angle between them is 150 degrees, determine the single force that can replace both of them. So here the data given, force P is equal to 200 newtons, whereas Q is equal to 100 newtons. So angle between the two given forces is equal to theta, that is 150 degrees. So here Q is equal to 100 newtons and P is equal to 200 newtons. Therefore, angle between the two given forces is given 150 degrees. Therefore, resultant R, and we have to find out the magnitude of the resultant. R is equal to root of P square plus Q square plus 2PQ cos theta. So remember, this formula is very important to find the magnitude of resultant. Therefore, R is equal to root of 200 square plus 100 square plus 2 into 200 into 100 cos 150 degrees is equal to 123.93 newtons. Therefore, angle made by R with respect to P is alpha is equal to tan inverse of Q sin theta by P plus Q cos theta. Therefore, alpha is equal to tan inverse of 100 sin 150 degrees 200 plus 100 cos 150 degrees is equal to 0.4409. That is the alpha angle value. So in degrees we will get 180 degrees. So let us see our another next topic. So it's continued from parallelogram forces. Next topic is triangle law of forces and polygon law of forces. So objectives in this class we will see state and explain triangle law of forces and polygon law of forces. That is, we know that the resultant of collinear forces is the algebraic sum of the given forces. So parallelogram law of forces gives the resultant of any two coplanar concurrent forces. That is, the triangle law of forces gives a graphical solution to determine resultant of two forces. So that is the triangle law of forces statement. If two forces acting simultaneously on a body are represented in magnitude and direction by two sides of a triangle taken in order, their resultant is represented in magnitude and direction by the third side of the triangle taken in opposite order. So here the two forces which are acting simultaneously, okay, on a body, so they represents the magnitude and direction by two sides of a triangle, but they taken in order. Their resultant is represented in magnitude and direction by the third side of the triangle taken in. So this is the triangle law of forces. In other words, triangle law of forces can be stated as if three forces acting at a point can be represented in magnitude and direction of three sides of a triangle taken in order, they will be in equilibrium. So the three forces which are acting on a point, so they can be represented in magnitude and direction of three sides of a triangle, so they are in equilibrium. So explanation: consider two forces P and Q acting simultaneously at a point. Let R be the resultant. So here you can see this forces P and Q, and the R is the resultant. So beta is the angle which is in between the point two forces P and Q. So draw a line AB parallel to force P and length proportional to magnitude of P, taking a certain scale. So it represents the R, the P and Q. Okay. So a line AB which is drawn. So the force which is there, P, it is proportional to the magnitude of P. So next, draw a line BC parallel to force Q such that its length is proportional to magnitude of force Q. So here, so this is the R and it is the P again and Q. In between the angle beta, so it represents A and B point and C point. So in between here, P and Q, okay, and it is the beta angle. So it is the force Q, it is a line BC parallel. Join AC which represents the resultant force R in magnitude and direction, that is the resultant R, P and Q, and this will be the beta. So R, P and Q, okay, and this is the A and B and C. So this will be the PQ ABC points which represents here. So in these, the angles which are represented here, you can see this one, the three forces which are there in between P, Q and R, that is the points A, B and C. So here the equilibrium is a force equal in magnitude and opposite in direction to the resultant. Therefore here P, Q and R, which shows the point A and C, that is R is equal to resultant force, and here we can see the forces of P and Q, so they are opposite in direction from the point here, the resultant R. And in this also we can see A and B and C. So E is the resultant which is acting towards downwards. Okay, this is downwards and here it is in the upwards. So whatever the force here, it is E is equal to equilibrium force. Okay, the R is the resultant force and E is the equilibrium force. Next one is Polygon Law of Forces. So here, if a body is acted upon by a number of forces such that they can be represented in magnitude and direction by the number of sides of a polygon taken in order, the closing side of the polygon taken in opposite order represents the resultant of forces in magnitude and direction. So that means if here a body is acted upon a number of forces such that they can be represented in magnitude and direction by the number of sides of a polygon. Okay, so they are taken in order. The closing side of the polygon, which is taken in opposite order, they represents the resultant of forces in magnitude and direction. That means here the point O, we can see F1, F2, F3, F4. Okay, so here the point F1, which represents again the point which represents to the F2 and F3, and it is called F4. So here the forces which acts represents the systematically. Okay, so here we can see this is the R, the remaining force which is there, that is the R. So from point of concurrence, these forces will be acting in different directions. So here Polygon Law of Forces is an extension of Triangle Law of Forces applicable to any number of forces. That means if a number of coplanar forces acting at a point be represented in magnitude and direction by number of sides of a closed polygon taken in order, then the system is said to be in equilibrium. So here the number of coplanar forces which are there, they are acting at a point, they are represented in magnitude and direction by the number of sides of a closed polygon, but taken in order, then the system is said to be in equilibrium. Then the next topic is Lam Is Theorem. Up to now we have seen the Triangle Law of Forces, Polygon Law of Forces. Now let us see Lam Is Theorem. So what is Lam Is Theorem? If three coplanar concurrent forces are in equilibrium, each force is proportional to the sine of angle between the remaining two forces. So this Lam Is Theorem is very important. Here, if three coplanar concurrent forces are in equilibrium, suppose, okay, and each force is proportional to the sine of angle between the remaining two forces. So let us see here. So here three coplanar concurrent forces are there. Those are alpha, beta and gamma. So we can see F1, F2 and three forces are acting at a point that is shown in the direction of F1 by, it is derived F1 by sine alpha, by F2 by sine beta and F3 by sine gamma. Example 1. A lighting fixture weighing 25 newtons hangs from a point R by two strings PR and QR. So PR is inclined at 60 degrees to the horizontal and QR at 30 degrees to the vertical as shown in the figure. So calculate the forces in the strings using Lamy's theorem. So he has given the 25 newtons hanging. So this is a 25 newtons. So the 3 points were there, that is P and Q and R. So PR and QR. So PR is inclined at 60 degrees and QR is 30 degrees. So we have to calculate the forces in the strings. That is F1 and F2 we have to calculate now. So given data, let F1 and F2 be the forces in PR and QR respectively. So angle between F1 and F2 is equal to 30 degrees plus 30 degrees is equal to 60 degrees. Therefore angle between lightning fixture and F1 is equal to 180 degrees minus 30 degrees is equal to 150 degrees. That is, so this one. Okay, the angle of fixture between the lightning is equal to So if this is 60 degrees, 30 degrees, remaining portion what 180 degrees. So we are taking from 180 degrees minus 30 degrees equal 150 degrees, and again angle between lightning fixture and F2 is equal to 180 degrees minus 30 degrees is equal to 150 degrees. So applying Lam's theorem, F1 by sine 150 degrees is equal to F2 by sine 150 degrees is equal to 25 by sine 60 degrees. That is F1 is equal to 25 by sine 60 degrees of sine 150 degrees is equal to 14.43 newtons. So this is the F1. Okay, 14.43 newtons is the F1. So this is in the tension. 25 by sine 60 degrees into sine 150 degrees is equal to 14.43 newtons tension. Therefore, F2 is equal to 25 by sine 60 degrees into sine 150 degrees is equal to 14.43 newtons in tension. So result finally, the force in PR is equal to 14.43 newtons tension, and in QR is equal to 14.43 newtons tension. So both are equal in tension. Next, example 2. A 20 newtons weight is suspended from ceiling by a chain as shown in figure. The chain makes an angle 45 degrees with the ceiling when it is pulled horizontal by a chord. Find the tensions in the chain and chord. So here we can see we have to find the tensions in the chain and chord, that is T1 and T2. So 20 newtons is hanging. So 45 degrees chain makes an angle. So given data, let T1 and T2 be the tensions in the chain and chord respectively. So angle between T1 and T2 is equal to 45 degrees plus 90 degrees is equal to 135 degrees. So where is the angle here? So this is a 45 degrees, where it is as 90 degrees. Okay, so in between these forces, 45 degrees plus 90 degrees is equal to 135, whereas angle between weight T2 is equal to 90 degrees. Solution. So here this is 135 degrees and this is also 135 degrees, and this is the 20 newtons. So T1 by sine 90, T2 by 1 sine 135, 20 by sine 135. It is, we will get T1 by 1 is equal to T2 by 0.7, 20 by 0.7 is equal to T1 is equal to, we will write this one, T1 is equal to 20 by 0.707, we will get 28.29 newtons. This is a value of T1. So where T2 is equal to, so substitute again here. So T2 is equal to, so you represents this 20 by 0.707 into where we got the 0.707 is equal to 20 newtons. So we will get the result, tension in the chain is equal to 28.29 newtons and the tension in the chord is equal to 20 newtons. So in this way we have to determine and calculate the T1 and T2s. Okay, so that means, so where is the T1? This is a T1 and this is a T2. So let us see the next topic, that is resultant of coplanar concurrent forces by resolution. So in this we will know about the resolution of a force, and we will calculate the horizontal and vertical components of a force and determination of the magnitude and direction of resultant of coplanar concurrent forces. So what is the resolution? That is process of splitting up a force into components without changing its effect. Therefore, force is generally resolved into components along two mutually perpendicular directions called rectangular components. So, the horizontal component of force along x-axis and vertical component of force along y-axis, that is, consider force F acting at an angle theta with x-axis as shown in figure. So this is Fx is equal to F cos theta, Fy is equal to F sin theta. So this is a theta where F is the force. So figure showing the given force and its resolved components. Since sin theta is equal to capital Fy by F, therefore Fy is equal to F sin theta. So here it is determined as cos theta is equal to Fxy F, therefore Fx is equal to Fx cos theta. Horizontal component of force Fx is equal to F cos theta. Vertical component of force Fv is equal to F sin theta. Resultant of two components gives the original force as F is equal to root of Fx square plus Fy square. So this is the resultant of two components original force. Analytical determination of the resultant of coplanar concurrent system of forces, that is, the point of concurrence of the force system is taken as the origin. That means the forces F1, F2, F3 and so on be resolved along x and y directions. Those are F1x is equal to F1 cos theta 1 and F1y is equal to F1 sin theta 1. Therefore, F2x is equal to F2 cos 2 theta and F2y is equal to F2 sin theta 2 and so on. Sigma Fx is equal to F1x plus F2x plus of so on, that is sigma Fv is equal to F1b plus F2b plus of so on is sign convention. The component along x-axis is taken as positive if it acts towards right. The component along y-axis is taken as positive if it acts upwards. The component along x-axis is taken as negative if it acts towards left. The component along y-axis is taken as negative if it acts downwards. So this is a sign convention we have to remember. So given the compound force is Fx and Fy. So here the resultant R is equal to root of sigma Fx square plus sigma Fy square. This is a formula to find out the resultant R. And here the direction of R can be determined by tan theta R is equal to sigma Fy by Fx, that is theta R is equal to tan inverse of sigma Fy by sigma Fx. So it is determined as theta R is equal to angle between R and X axis. So here we see a problem. Resolve each of the forces in the following system of forces along X and Y axis and assign them signs. So here we can see the forces and loads are given. So X and Y 30 kilonewtons, 40 kilonewtons, 60 kilonewtons and 20 kilonewtons. So here for force 30 kilonewtons, where is the force 30 kilonewtons? This is the force, okay, first one. So here component along x-axis is 30 cos 45 degrees. So how much angle was given here? 45 degrees. So 30 cos 45 degrees is equal to 21.21 kilonewtons acting right and hence positive. So next, component along y-axis is 30 sine 45 degrees. So here we have to find out the cos and we have to find out the sine. So then we will get plus 21.2 kilonewtons, hence upwards positive. So meanwhile, same like that for 20 kilonewtons also, angle with respect to x-axis 90 degrees minus 60 degrees is equal to 30 degrees. So component along x-axis is 20 cos 30 degrees is equal to minus 17.32 kilonewtons. So it is acting at left, hence negative. And along y-axis 20 sine 30 degrees, it is plus 10 kilonewtons, hence positive. So for 460 kilonewtons, x-axis 60 cos 60 degrees is equal to minus 30 kilonewtons, hence negative. So along y-axis 60 sine 60 degrees 51.96 kilonewtons, it is hence negative. So far we have discussed resolving a given force into rectangular components. Okay, so assigning the signs to the component forces by following a different sign convention. So these are our resultant forces. So thank you, have a nice day.